Hello. Hello, hello. Thank you all for coming. I'm Sarah Lima, and I'm a developer and a team lead at ThoughtBot, along with Louis as well. And I've been working developing software for like over a decade now. And I first fell in love with Ruby like around 8 years ago. Can I just have a show of hands? Like, how many of you have worked with Ruby like for more than 2 years? Nice, almost everybody. Like 5 years, 10 years. Oh, that's a lot of people. That's very nice. I'm from this gorgeous tropical city called Natal in Brazil, very far away from here. But last year I moved to Porto, Portugal, and it's just another very charming city. And there I spend a good chunk of my time, on my free time, playing volleyball with this lovely bunch of people there. Don't get fooled by my height. I love playing volleyball. And I'm really happy to be here in Helsinki for Tiny Ruby today. And this is by far the northernmost place I have ever been. I've been on the globe so far. Yeah, just like many of you, Ruby is the language that I enjoy working with the most. I'm just very passionate about it, and just because of how much I love working with it, I'm always trying to understand it on a deeper level, and just not the how they things, like how they're done, but also the why, and the hope that people that read my code will enjoy working with it as much as I love Ruby. And today I like to talk about Booleans. It's a concept that we learn usually early on in our journeys, and how the way that Ruby does it, what does it teaches us on how to write better Ruby software. But Booleans are only the starting point. What I'm passionate about, or like to talk about today as well, is object-oriented design. And to get started, let's review how conditions work. It's also something that looks basic, but bear with me. We are gonna talk about their behavior, how they actually work in our applications. Let's look at their internals, and let's try to build our own. So in a conditional, we got usually that structure. We got a test expression, and we have a then expression, right? And then the then expression is evaluated every time that the test expression is truthy. So if you give it an empty string, a zero, or even an empty array, the then expression is always evaluated, except when given false or nil. And if you always work with Ruby, that's just like obvious, not surprising at all. But it's important to notice that this works differently in other popular and kind of similar languages like Python. But in Python, this is just like interpreted as, okay, we don't care, we don't want to evaluate that block when we have a zero value. In JavaScript as well, right? And we can look into Ruby's internals to see how this is implemented. Have you all looked into Ruby code, like C code before? Oh, only some of you. That's nice. Enough people. And we are now looking at C code, right? And we see an RB test function where object is a Ruby value, the ampersand is bitwise AND, and the tilde is the bitwise NOT, and Ruby QNIL stands for the literal bit pattern representing Ruby's nil. And to understand that function better, we need to know about object identifiers. Every object in Ruby has a number assigned to it, and the interpreter uses that number sometimes for optimizations. And we can see that in practice with the object ID method. And we can just call this method on any object in our application. We're going to get an integer back. So let's apply that logic we saw before in C. And for instance, an empty array, a zero, or an empty string. And we see that in these cases, applying that same logic, this will always return a non-zero integer. And these are the two single cases where this function will return a 0. Okay, so we saw these are integers, but the return type in C is bool. So the fact is, this is because in C, Booleans are numbers, and 0 is false, and everything else is truthy. And with that, we understand that in Ruby, we have these two types of values. We have false or new, that are the only two things in Ruby that are falsy, and everything else is truthy. All right, so we took a look at the behavior, at how it's done. What more can we learn about the way that Ruby designed Booleans? So we know that in Ruby, everything is an object. That means that the literals true, false, and new, they are objects as well, and they're instances of a class, true class, false class, and new class. And they are singleton classes, meaning there is only one instance of them, and there's no way to instantiate them like as we would with a class. We can only instantiate them using the literals. So nice. Let's try to build our own conditionals. Let's just open these very basic classes, true class and false class. And how can we do it using object-oriented principles? Let's just send messages to these objects. We're gonna open true class first, and we're gonna implement our if-true method. And this if-true method will take in an implicit block and will yield to the block. Yeah, and then we're gonna just do the same, implement the same API to false class. But in this case, we are not gonna yield to the block. We're just not gonna do anything, just return new. So we saw that we had true, false, and we had new as well, right? We have to be able to send the same message to new. So we have to implement that in the new class. And we have to be able to negate as well, like check for the falseness of our object. And we're gonna implement the if false, which is just gonna do the opposite. In true class, this is gonna, if false, is not gonna return anything, and so on. You get the gist. And this code is adapted from Yehuda Katz's blog, emulating small talk conditionals in Ruby. I really like that blog post. And if you don't believe me, this actually works. 1 equals 1, we can send a message to that, which is gonna be evaluated to true, right? And the block is going to be evaluated. We are going to print this is evaluated. And the other way around, if we give it a false expression, the block is not going to be evaluated. Same with nil. But this isn't exactly right yet. We have to be able to run conditionals in any objects on our application. But so far, these messages would only be able to be sent to true, false, and nil. So it's easy. Let's hack this up. Let's open the object class and implement the same logic that we had on the true class. So now we are able to send these messages to any condition, to any object in our application. And yeah, so that's kind of interesting, but that's not actually the way Ruby does it. What's actually the API on these 3 classes? What do they have in common? What makes them kind of act like Booleans? We can call the dot methods method, and we see that these are the 3 methods that they have in common: the ampersand nil, the ampersand symbol, the pipe, and the caret, which stands for the and, the or, and the exclusive or. And we can call them like that: dot, ampersand, and then a value, dot pipe, dot caret. And I just think that's very cool that we are able to do that, to send messages like that to any object. And if we know that like under the hood, that's actually what's happening, right? We have a message send with the name of a method and then a parameter. And when we realize that these three classes are actually just descendants from object, they don't have a superclass like some people may wonder, but doesn't Ruby have a Boolean class that would just like be a superclass to true and false, for instance? And we don't. So the purpose of a class is that we want to group similar objects together with the similar behavior. And I just saw true and false are actually not similar. They are the opposite. They just have completely opposite behaviors. So they just don't belong in the same class. I think that makes a lot of sense to me. We see that on if true, if false, and the other way around. But what if I like to perform a type check? I think checking types just goes against Ruby's philosophy, and it encourages us to think in terms of messages to send to objects and not objects that fit into just rigid hierarchies. And if we wrote something like that, we just be slipping into a static typing mindset and not thinking in terms of messages that we want to send to objects and behaviors to rely on. And then, so Ruby's approach is different when any object can stand in for truthy or falsy, as long as it responds to the implicit "Are you true?" message that if sends, right? And by avoiding a superclass, like a Boolean superclass, Ruby just nudges away from the brittleness that type checking gives us, and just trust them. We should just trust our objects to respond meaningfully. If you like to read about this further, if you're not sold on the idea, if I didn't explain it very well, you can take a look at these two links and read it about, like, there's a change request made on the Ruby Lang forum asking to create a Boolean superclass, and then I think there's a reply from Mats itself. Yeah, there's a lot of comments, a lot of discussion about that. I think it makes sense to me the why we don't have that superclass. But how does that relate actually to our day-to-day application code? So let's say I'm working on building integrations for two APIs, like a weather service, a payment service. And I first just like start wanting to be clean and architecturally elegant. I just create a superclass, like a base API class that all of my integrations are gonna inherit from. And at first, it feels brilliant. I just have to write that superclass, and then my payment classes, payment and weather API just inherit from it. Client is happy, team is happy. We, however, just see the cracks appearing very quickly when, for instance, we have a change request. Like the payment service just requires OAuth tokens refreshed every hour, or the weather service, it requires API keys in the headers. So we just noticed that our base class just like becomes different, and then we just have to have a lot of conditionals and type checks. So we are not actually having a clean abstraction anymore. We are just forcing classes that are actually different into the same mode. And every new API that we add just makes the base class harder to reason about. Now, I'm not saying that if you have a base API class, you should get rid of it. But I'm just saying that just like Ruby treats true and false, that kind of may look at first glance similar, Ruby just treats it as two separate concrete classes, right? In this case, our class should be separated as well. Creating a forced parent class that for things that are just different actually is going to lead to leaky abstractions and endless conditionals in our code, and just makes us very mad, and yeah, doesn't make our life enjoyable. So if we're writing Ruby code, it's important to know how to take advantage of object-oriented design and learn how to model our classes and objects to avoid these endless conditionals. So in reality, maybe that's what we want, just different classes, different objects, no super class needed. And we may think, oh, but we're gonna have just duplicated code now. The shared headers or the shared error handling, and just this duplication may just be so much easier to deal with than just the wrong abstraction. Another pitfall that we can avoid is related to type checking, is primitive obsession as well. There sometimes go hand in hand. That it also leads to just endless conditionals. This is another example, a real life application example. If we're, like, for instance, building an app to get reviews from users, and we have like 4 types of answers that we get from these reviews, users may say like, okay, I like the application, that stands in for true, I didn't like it, false, nil, I skipped it, but we still want to store that data, and we may just take in strings as well with comments. So if we're going to a more procedural route and just want to do type checking, we may write our code like that, doing type check. If we got true or false, we just count our votes. If given a nil, we just log somewhere, user skipped it. And then if we get a string, we want to add it to an array of comments. Here we're just doing type checking, we're not sending messages, we're not taking advantage of object-oriented design. And this may just be fine if we're just writing that small of a script. That's not over-engineering, it's fine. But if we're working on a big application, which I think most of us do, like in our day-to-day development lives, this means that probably these type checks were just gonna breed across all of the application, and every time we have to add new types of reviews, for instance, we are just gonna have to check all of the conditionals and add there, which is probably gonna cause something called shotgun surgery. It's just very annoying to deal with that. So what can we do to avoid that? We may just create objects, and each object is just gonna know how to deal with its own processing, and we may just have an array of all of these objects, and then call .process in every one of them, which may have drawbacks as well. It's really easy to add new types. We just create a new class and implement our behavior in that new class. We don't have to refactor everything. But adding new behaviors, if you have a lot of different classes, then it may be a little more of work. But anyway, in a lot of cases, it still makes sense to replace conditionals with polymorphism. And depending on these polymorphic interfaces may just help us to create classes that don't need changing when the application changes. So, yep, a conclusion, actually, parting thoughts, is that Ruby is beautiful. We all love it. And I really like us to think about making our application code as well as enjoyable to work with, as much as the Ruby is enjoyable to work with, by mostly leveraging object-oriented design. These are some of my references, and just shout out to specifically to my Topbot blog. I learned so much with it since like before I joined them. And Sandy Metz as well, just like if you are interested in object oriented design, if you don't know her, like you're just missing out on so much. Yeah, thank you. Let's keep in touch.